In the last video, we saw this formula for the confidence interval for population proportion, but we haven't quite used it yet. We saw some of the conditions that are required to use it, the margin of error piece, which is that plus or minus piece in the back, and then we spent some time figuring out how to find z critical values, which is an important skill to have because those z critical values are going to get used through chapters 9 and 10 and 11 and so on. All right, so now let's actually get closer to making a confidence interval. So we're going to use that little scoop that we have from a big box of beans. Let me just pull up the picture right here. So we have this little scoop and this big box, right? So that's the sample. And we want to verify the conditions are met in order to construct a confidence interval. Well, there are three conditions that are needing to be met. That you need to know that you have a simple random sample. You need to know n times p times 1 minus p, oopsie, is greater than 10. And then you need little n, which is your sample size, to be less than or equal to 5% of your population size. So let's figure these ones out. Okay, so the first condition that we wanted to meet was we wanted to know that we had a simple random sample of size n. Well, in other words, we really want to know, do we have a simple random sample, right? And the answer to that is yes. It's stated in the problem, not right in here, but when we first ran into it, that stated in the problem that the sample is random. Fine. Then we also want to know that little n, which is your sample size, is less than or equal to 5% of your population size. And again, we have a scoop of 120. It's a little bit hard to gauge from looking at this, but trust me, 120 is far less. This little scoop is far less than 5% of this entire box. This is a huge amount of beans, and that little scoop is not very much. And that little discussion we just had there is a little bit, well, we call it hand waving in math class. You know, you kind of wave your hands at it like a magician and say, well, of course, ta-da. But if they gave us the population size, then we would actually use it. So that gives us a couple things to note. So we often just assume these two conditions are met. We often don't really bother with them very much. That's okay, you know, I mean, it happens. And then when we do bother with them, if they gave us population size, if capital N was given, we would substitute it and double check into the formula to check the values. So like if they said capital N is 20,000, you would find 5% of 20,000 and make sure that your sample size is less than that, which it is in this case, but you know, you would check it. All right, now the other condition we need is that we need that little n times little p times 1 minus p is greater than or equal to 10 in order to ensure normality. So little n was 120, p was 0.25, p hat, excuse me, was 0.25. 1 minus p hat is 1 minus 0.25. So I need to know those numbers. 120 times 0.25 times 1 minus 0.25. I don't really need the time symbols in there, but that's okay. And I get 22.5. Well, 22.5 is definitely bigger than 10. So that's a good thing because we wanted to have a number bigger than 10. Otherwise, we wouldn't know that it was normal. So the answer to that is a big whopping yes. And that, again, is to ensure that it's normal. If the data set is normal, so z alpha over 2 is a valid condition to use. Is valid, right? You can't use the z curve unless you know that this is true, right? N times p times 1 minus p is greater than 10 if you're working with proportions. And therefore, since it was, we're good. We can totally use it. All right, now that we know those things, we want to go find the actual confidence interval for once. We're going to really finally do it. Use the formula, show the formula, the substitution, and the final result. So here it is. So you start off with the formula. Now the formula is back here, right here in this box, or it is on your inferential statistics cheat sheet, info sheet, whatever you want to call it, right here, top left corner. That's the one. So we're going to use that and then I'm going to substitute. So formula, substitute, answer. So I'm going to show the formula part. The formula is p hat times 1 plus or minus z alpha over 2 x over this, or excuse me, p hat times 1 minus p hat all over n, take the square root of that. What a mess. All right, so now let's do the substitution. So this is where you plug in all the values. So I can take this. Now p hat I know is 0.25. So wherever there was a p hat, I can put 0.25, 1 minus 0.25. And then n I know was 7, oh no, it was 120. That's what it was. 120. That was the number of beans in my little scoop. So what I have to go do now is figure out the z. But the z was because it's a 95% confidence level. See right here, 95%. Because of that, we know that the z we want is 95% z level, means that z alpha over 2 is equal to 1.96. We found that back a couple pages ago, or actually a page ago. Right? So if you have a 95% confidence level, that means that your z alpha over 2 is 1.96. We found that just a page ago, right here, using inverse norm 0.975 and so on. And again, you don't have to show all the work. Once you know those three, you know them. So this one's 1.96. So that's where that comes from that 95% confidence level. So I'm going to use 1.96 in here. Now, as great a student as you are, I'm going to tell you right now that a lot of very good students mess up entering this calculation into their calculator. They're just not good at it. That's okay. I mean, it's easy to make mistakes in a calculation that's that complex. So the easier thing to do and the wiser thing to do would be to use the calculator. The calculator has some special features, and this is your first one of them, and you're going to be using a lot of them. So let me press Stat. We've used edit before, that's where we've entered data before, and we've used calculate, number 1, and number 4. Those are two big ones we've used. And now we're going to go one more to the right to tests. And this is where you're going to be spending all your time from chapter 9 onward. So you can look through, there's a whole bunch of stuff in here going on. There's intervals, see those intervals? And we want one called the one prop z int. It'll be in different places in different calculators. For me, it's under letter A, the one prop z int, one proportion z interval. Now, how would you know it's that one? Well, because I tell you right here on the inferential statistics sheet, right here. And remember, you get to use this on your exam. There's a reason for it. It's neon green in your course pack. Pull it out, staple it, put your name on it. You get to use it. So it's one prop z int. That is the one for this formula. So I'm going to grab that. One prop z int. Then it wants to know what your x is, what your n is, and what your confidence level is. So remember, x is the number that have the quality that you are interested in. So if you remember, it's been a while since we saw it, but p hat was equal to x over n. X was the number of red beads in our sample, which was 30 right here, and n was 120 right here. That'll get us p hat, which is 30 over 120. So let me grab the calculator. I'm going to type 30 is my x, 120 is my y, or my n. My confidence level is 0.95, and I go down to calculate, and there I have it. And notice it tells me p hat is 0.25, and it tells me that n was 120. And then it tells me the confidence interval is 0.17253 to 0.32747. So I'm going to put that right in here. Sorry, I gotta flip to the right page. There it is. I don't actually want the calculator entry. I just wanted it so I could see what I was doing. So 17253, comma, 0.32747. And that is the final result. And then I don't really need the calculator piece to go with it. It was just there. All right, so you put your formula, write it all down. Your substitution, you fill in every piece of it, your final result. That is how you will do these when you do them by hand, quote unquote. And of course, you're free to use the calculator to do all the heavy calculation part. All right, now there are a couple things to note about this formula when you use it with the calculator. So let me run into them. There we go. To fit it all in, I had to move this up a little bit. Okay, so let's see here. That's all the instructions we saw, but remember a couple things. P hat is x over n. That's where the x and the n come from. And x and n must be whole numbers. They must be. So that means if they weren't whole numbers, you would round them and make them whole numbers. And n is always the bigger of the two. N is your sample size total. X is just the people or the pieces of the sample that had the characteristic you were looking for. All right, so now that we know how to find the confidence interval and find it with the calculator, show all the work, etc., the question comes up of what does this confidence interval mean in the context of the situation? So we are 95% confident that the true proportion of, now what was this about? Red beans. So the true proportion of red beans in the box. And of course, that's a metaphor for the true proportion of people that are going to vote for so-and-so, or the true proportion of people that believe this, that kind of thing. True proportion of red beans in the box is between 17.3% and 32.7%. And now you see where I got those numbers from before, right? Well, you will see them in just a minute. Now the point estimate is p hat. Now how could we find it? Now we already know that p hat is x over n, but you could also find it using the interval. Let me show you. All right, there we have it. So we have the formula. We've seen that before, which is p hat equals x over n. If you know x is 30 and n is 120, you could just divide them and get 0.25. No trouble. Now how could you do it if you were just given the interval? Well, if you had the interval, remember that the point estimate is in the middle, right? So to find the middle of the interval, the exact middle of interval, what you do is you take the low number plus the high number and you add them up and divide by 2. So you'd say 0.173 plus 0.327, add them up and divide by 2, and you'll get your p hat in the middle, which is 0.25. So that's another way to do it. If, for example, you did not have x and n, this is how you'd have to do it. So if I give you the interval, but I don't give you x and n, then this is the only way you know how to do it, which is to use the fact that it must be the center of your interval to find it. And I just redrew this picture from before just so you could see it again. So 0.327 is on the high end, 0.173 is on the low end, and the point estimate is the number that is right in the center.